Hello guys, welcome to Coder Journey. This is episode number 1 of a course that I have decided to create about clean architecture. So in the other courses that I have on my channel, I have talked about the clean architecture from time to time. And I have used some, different techniques coming from this architecture. So I decided to dedicate one course, one playlist to this architecture, implementing the ideas behind this architecture inside of an application. So as you can see right now, I've got my note for episode number 1, but here on my other display, I have this project inside of Visual Studio. So if you have watched any of my courses, any one of my courses, you are already familiar with the Pirus company. So this is like a company that we have taken as an example throughout some of the courses that we've got, and we have used it. For example, inside of the modular monolith course, I have used this company. Here in this course, we are going to implement the ideas of clean architecture inside of this project as well. And we're going to have different branches for this playlist in our solution, as you can see here. So for now, I am on episode 5 branch, and we're going to complete this course by adding new branches here as well. Right now, I have prepared the materials for 6 episodes. So the first 4 episodes from number 1 to number 4 are all about theoretical stuff. So things that you need to understand in order to be able to implement the ideas behind clean architecture inside of a project. So this means that we are not going to write any code from episode number 1, but of course I am going to show you some code snippets. But we're gonna, dive deep into the implementation starting from episode number 5. So if you're familiar with the topics and concepts of clean architecture, you can skip to episode number 5, but I highly recommend that you watch the videos in order. So from episode 1, 2, 3, and so on. And another thing that I want to tell you is that the code files, the solution files of this project can be found in the link that I have provided in the description of this video. So if you want to get the solution files, you can go to the description of the video, and then you can clone the code on your machine and then navigate the different branches and learn this stuff. So now let's talk about clean architecture, episode number 1, and then we will, as I told you, little by little, move to more practical, stuff that require actual code and implementing, the ideas inside of our project in Visual Studio. So let's talk about clean architecture. The importance of software architecture. Let's first talk about software architecture. So software architecture is critical for the success of developing a robust, scalable, and maintainable software application. A solid architecture provides separation of concerns, separating different parts of your application, different concerns, like for example, your domain entities from your DTOs. I have done this inside of the courses that I've got on my channel, separating your commands from your queries using something like CQRS, the mediator library, again, another course that you can, use on my channel. So the separation of concerns is a very important, principle that the clean architecture helps us achieve. So the first one is separation of concerns. Debugging and testing will be easier because of the the dependencies that we are going to have and the relationship between those dependencies. You will see this in action when we get to the writing code phase. Better collaboration among developers. So if you've got different developers working on the same application, they can easily write tests, write production code, collaborate with one another, which can of course be very, it is something that teams desire to be able to do in order to expedite the process of developing the software application. New developers can join the team swiftly and rapidly because everything is very organized. You will see this. And then, of course, flexibility for accommodating future changes, because change is the only constant when it comes to software development. So using a robust architecture like the clean architecture, accommodating for new requirements and changes is going to be a breeze. So without having a good architecture, so of course in our case clean architecture, projects will become very brittle. So like a change will probably like result in a total failure of your project. The code will be difficult to maintain and difficult to scale. So a good architecture based on the requirements of your business can go a long way when it comes to having a successful software architecture. Now we are going to talk about clean architecture specifically. Clean architecture is a style of software design introduced by Robert Martin, or Uncle Bob. And in this, architecture, the application is going to be developed in concentric circles. So each circle constitutes like a layer inside of the application, and each layer has a clear responsibility and a strict rules about the dependencies, the dependency graph, the like direction of the dependencies. The innermost layers are going to be our domain layers and our application layers. These layers contain business rules. For example, your domain entity, you will see this. If, for example, you take a look here, you can see that right now inside of this domain project, I've got my employee as the first entity, right? So this is my domain entity. This is one of the, innermost layers of my application, and other layers, like for example, let's say the infrastructure, the user interface of the application are going to depend on this innermost layer. So this layer doesn't depend on the interface, but the interface of the application, either the UI of the application, or like if we are developing a web API, the endpoints of the application depend on this domain layer, this domain entity. So again, innermost layers, right? These are going to be independent. These contain business rules, and other layers depend on this layer. If these topics seem to be a little bit, let's say difficult to understand and a little bit confusing, bear with me, because when we get to the coding phase of this series, all of these ambiguous and vague topics are going to start to make more sense. The outer layers, infrastructure, if you are integrating with a database, if you are integrating with like an external service, right? These contain implementation details, such as frameworks, database calls, external tools. So the outer layers, as I told you, the outer layers depend on the inner layers. This is very important. We are going to develop the application in kind of concentric circles, with the domain layers sitting inside of the other bigger circles, which are the infrastructure and the UI layers. Let's talk about one key principle when it comes to developing a software based on the clean architecture guidelines. The one very important principle is that when it comes to clean architecture, dependencies must point inward. As I told you, outer layers like infrastructure or UI depend or can depend on inner layers like your application services, your domain entities, but not the reverse, meaning that your domain entity cannot depend on the outer layers. This means that, when the UI depends on the entities on your inner layers, it means that when the UI changes, for example, from like a React application to an Angular, your domain layer, which contains the entities, the application services, the repositories, these do not need to change. So this is very important to grasp. And as I told you, and if this seems to be a little bit confusing, no worries, because little by little, when we implement these, things will start to make more sense. This design ensures that business logic remains isolated from external resources. Clean architecture versus layered architecture. So we've got a comparison of clean architecture and the layered architecture. In clean architecture, we are going to develop the application with concentric circles. In layered architecture, we're going to have different vertical layers like user interface, business logic layer, data access layer, and so on. And things are going to depend on one another from top to bottom. For example, the UI is going to depend on the BLL or business logic layer. The business logic layer is going to depend on the data access layer. But in clean architecture, the domain will sit at the center, and then other layers will depend on the domain. Dependencies, as I told you, UI depends on DLL, which depends on DAL or data access layer. In clean architecture, all dependencies point inward towards the domain. Testability, tight coupling makes testing harder. In terms of clean architecture, because business logic is independent, because the domain which contains the business logic doesn't depend on anything, is autonomous, the testing part will be very easy. Flexibility, so difficult to change. A layered architecture is difficult to change because of the different layers that you have. A change in a layer can cascade other changes in other layers, but in clean architecture, external tools can be swapped easily. Last but not least, clean architecture is domain-centric, is business-centric, but layered architecture is technology-centric. So clean architecture solves many of the problems that we previously had to deal with in traditional layered architecture. And now the benefits of clean architecture. Testability. It is very testable. You can write unit tests, integration tests. Even without integrating with infrastructure, you can write unit tests. Framework independence. It doesn't depend on any framework. You implement your domain logic independently of any specific technology. It is UI independent. Again, you do not need to have one specific user interface technology. You can have your domain developed, and then you can swap the UI layer. So you can have like a React application, a Razor Pages application, and so on. It doesn't depend on any specific, again, database. As you can see, it is database independence, right? It has this as the next benefit, database independence. You can use different types of databases, relational, document-based. You can use ORMs, object relational mappers, and so on. Maintainability, because you have separated many different concerns, because you have isolated them, you can, your code will be very maintainable. You will have fewer and fewer ripple effects, meaning that when you make a change to one part of the application, other parts will not necessarily change. So these are a list. These are some of the benefits of the clean architecture. This list, of course, is not exhaustive. There are many other advantages as well, but I decided to go with these one for this list. So when should you use clean architecture? As I have told you before, everything in software development is a trade-off. So you cannot say that clean architecture is the single solution when it comes to developing a successful software application. For example, you can kind of have an application where the layered architecture will be more suitable. But let's see when we can use or when we should use the clean architecture. You should consider using clean architecture when the system is expected to grow in size and complexity. Clean architecture is very suitable for microservices, for example. You want to future-proof the application against framework or technology changes. If you think that in the future the technologies that you are using will undergo tremendous changes, using clean architecture can help you because you can isolate those changes and those changes will not cause ripple effects. If you want to prioritize maintainability, testability, scalability, if these characteristics, these ITs as they're sometimes called, are important for your application, the clean architecture is a suitable choice. If you're working inside of an application using the patterns coming from domain-driven design or enterprise-grade systems, again, the clean architecture is a good choice. So as I have told you before, it may not be the best fit for every application, especially for simple application. It will be an overkill. If you want to have short-term MVPs, you do not need to necessarily go with the clean architecture because upfront you will have to spend a lot of time. So you need to, as always, evaluate the pros and cons and see if the time that you need to spend developing an application using the clean architecture justifies the benefits that you will have. Last but not least, the common layers in a clean architecture solution. So there are going to be like 4 core layers. The domain layer, this is, I think, the most important layer. It contains the core business logic, includes entities, value object, domain services, interfaces, exceptions, and enumerations. We are going to implement each one of these inside of the application that I have created here in Visual Studio. So you will see examples of entities, value objects, domain services, interfaces, exceptions, and enumerations, little by little. So not only you will understand the idea behind each one of these concepts, but also you will be able to implement them inside of a real project. Next, application layer. This application layer kind of coordinates the application specific logic and orchestrates use cases. So you will have use cases classes here, application services, interfaces for repositories and services. Again, I'm going to show you how to implement this. Again, as you can see here, this layer depends on the domain layer, but not the infrastructure or UI layer. If you take a look here, this is the most abstract and stable layer. This will not change. The domain layer will stay consistent because it doesn't depend on anything. But the application layer would depend on the domain layer. Next, presentation layer. So the presentation layer, again, it depends on the technologies that you use. The presentation layer could contain controllers if you are using MVC or web API, application, either web API or web application. View models, DTOs, all of these will reside inside of your presentation layer. So this handles the input and output. It is the entry point to your system, like the web API or UI, like Razor pages or controllers. It communicates with the application layer, with your services, for example, and of course it has no business logic directly. So your business logic will be inside of your domain layer. Next, infrastructure layer. So the purpose of the infrastructure layer is that it is to implement all of the technical details, like the interaction with database, messaging systems like RabbitMQ, file systems, and so on. So it can include database access code, messaging code, email, SMS services, cloud storage providers, and so on. This is where the system integrates with the outside world. This is one of the outermost layers, right? So this outermost layer will change, right? Will change based on the changes that these technologies will introduce. But the changes inside of the infrastructure layer, which is an outer layer, will not propagate to any changes to the domain layer because of the direction of the dependencies. So the infrastructure layer depends on the domain, not the other way around. A change in the infrastructure layer doesn't necessarily mean that you need to go and change your domain layer, right? So your domain layer will kind of be protected from the changes in the different technologies. So these are the different, layers that you can have. Of course, there could be other layers. Sometimes you can combine some of these layers together. Again, it depends on the project that you are going to develop. If the project is going to be very complex and it needs to be scalable, of course you can make more separation of concern. Again, you need to think and evaluate if the pros of splitting things will be justifiable or not. And we're going to wrap up this video. Again, as I told you during the first 4 episodes, the things we're going to talk about are going to be a little bit theoretical, but bear with me because from episode number 5, we are going to go to Visual Studio and we're going to start developing the ideas one by one inside of a real application. There are so many things to learn and I have a lot of things to share with you. So that's it for this episode. If you enjoyed watching it, please give it a thumbs up and stay tuned for the next episode in this series.